Hey guys, I just wanted to go through the few slides of the PowerPoint that are important for you to take notes on today. I decided not to do it on the HoverCam like I normally would because it's just all here and it's nothing that complicated, but it's stuff that you need to definitely get in your notes. So I'm going to go through this. There are some slides that we're cutting out. I kind of referenced it yesterday, how we're not doing anything with equilibrium when I couldn't really explain to you why these facts happen for the water constant, that KW. Same thing here. There's things in this PowerPoint that are above what we're teaching you this year. You'll learn it all in AP, not a big deal. But I want to talk about acid and base strength for a minute. Okay, remember there are the 7 strong acids and 7 strong bases that you just have to memorize. In college, they'll teach you why they're strong, what makes them strong or weak. Okay, not here. So let's talk about acids first. You need to write down what a monoprotic acid is and a polyprotic acid is. Okay, monoprotic, mono literally means one. You've learned that already. That means they have 1 hydrogen to donate. Like, that's it. When they donate that hydrogen, they have no more hydrogens left to donate. Poly, meaning multiple, polyprotic acids have more than 1 hydrogen. Okay? Again, you already know this, but they only go one at a time. Okay? Bases can release all of their hydroxides at the same time. Acids cannot. They must be ionizable, right? They must be able to dissociate. They must be able to be broken off of that compound. I wouldn't stress too much about this next slide, about knowing which one is ionizable and which one is not, because it's complicated, okay? You literally did this already yesterday in your warm-up, okay? You already know this. You know that if you have 3 ionizable hydrogens, if you're a polyprotic acid with 3 ionizable hydrogens, you still release them only 1 at a time, okay? These are monoprotic and polyprotic. I don't know why these are highlighted red. Okay, so there is another thing you need to understand about strong acids versus weak acids. Both of these glasses contain acids with the same molarity, right? They have the same concentration. So why is this one lighting up this light bulb so much more brightly than the acetic acid? The hydrochloric acid is very bright, the acetic acid is very dim. Same molarity. Okay, so the reason for this is because strong acids completely dissociate, right? They completely break apart in solution. So that hydrochloric acid in that solution of water is broken up into all hydrogen ions and chlorine ions. Okay, so the more ions you have, the more electricity you can conduct, right? The more electrolytes you have. Weak acids still ionize a little bit, right? There's some hydrogens floating around and some acetates floating around in the acetic acid, but some of them haven't. Okay, so there's fewer ions. So if you want to pause this video, make sure you've taken the notes on this. This is important. Like, you definitely have to know this. Strong acids completely ionize, therefore they're stronger electrolytes. Weak acids do not completely ionize. They still do a little bit, therefore they are weak electrolytes. This is getting into the stuff that you don't have to know, okay? Although this is a great particle diagram, I would maybe sketch it. This is showing, it's 2:45. This is showing that complete ionization from the hydrogen from its anion, okay? This is showing you only the partial dissociation or partial ionization from the hydrogen and its anion. So I would sketch that. But this is getting into what you don't need to know. We're not getting into equilibrium, okay? Here's your slide that you need to memorize. There's 7 acids. Notice that you have a lot of chlorine-related acids, okay? And then chlorine, bromine, and iodine. I'm trying to just give you some tidbits here. chlorine, bromine, and iodine, they're all halogens, right? And then sulfuric and nitric acid, just need to memorize. This is all like, whoa, lots of extra stuff. This is all equilibrium and talking about acid strength. Don't have to know it, don't have to know it, don't have to know it, don't have to know it. This is important. If you need to pause this and write these down, please do. You need to know that if you have an extremely strong acid, so sulfuric acid, its conjugate base is going to be a very weak conjugate base. Okay, vice versa. If you have a really weak acid, like hydrochloric acid, then its conjugate base is going to be very strong. Okay? So you need to know that, that the strong acid conjugate base is weaker than water, which is weaker than the weak acid conjugate base. Okay? This is more with like the equilibrium values. Don't have to really worry about that. More of that. Now on to bases. And bases aren't that much different. They follow a lot of the same concepts. Okay, here are your strong bases that you need to memorize. And I just wanted to point out to you that all of those strong bases come from, where am I? Oh my goodness. Come from groups 1 and 2. I'm like backwards on here, I can't even tell what I'm doing. They come from groups 1 and 2. Now, not all of the alkali metals group 1 are strong, and not all the alkaline earth metals from group 2 are strong bases, but they're dabbled in there. Okay, so it starts at sodium, goes down to cesium, and then over to barium, and up to calcium. Okay, so if you can just make yourself a little pattern on this periodic table, starting at sodium, going down to cesium, like cease, stop, go over to barium and up to calcium, those are your cations that bond with hydroxide to form a strong base. Okay, and again, your strong bases completely ionize or dissociate in solution. That's what makes them a strong base, strong electrolyte. Okay. Whoa, too much. Skip. This you need to know, right? The exact same concept as the conjugate strength of your acids. If you have a very strong base, you're going to have a very weak conjugate acid. A very weak base, you're going to have a very strong conjugate acid. That's the end. So if you need to go back, or if you need to actually access the PowerPoint and take some more notes, you can. The rest of class, guys, I would work through the pH calculation worksheet, and the key is linked to yesterday, I think, to every single problem. Worked out nicely. So remember, there were a few little challenging parts, like you might have to have a 2-step part every once in a while, or you might have to notice that there's 2 or 3 hydroxides, so that means you have to take the concentration and multiply it by that number of hydroxides, because they're released all at once, right? Like their molarity happens all at once. So you have 3 or 2 or whatever. I'm being like very like dramatic. I'm sorry. And then tomorrow you have your quiz, right? Your big, like all the acid theories, probably some writing and naming, definitely pH calculations on the quiz tomorrow. Alright guys, talk to you later.